In the previous video, I have explained you how does resistivity varies with temperature. We have seen that for conductor, resistivity or resistance increases with respect to temperature. Here we are going to see the mathematical representation that connect resistance with temperature. Okay. Now, so first we are going to define a standard conductor having 1 ohm resistance. Now we are going to do an experiment after increasing the temperature through 1 degree Celsius. What is this? Let's say we have a conductor with 1 ohm resistance. Now the temperature is 27 degrees Celsius. We are going to raise the temperature to 28 degrees Celsius and going to measure the new value of resistance. Let's say the new value of resistance or the change in resistance. Okay, change in resistance if it is alpha. What is the new value of resistance? Change if it is alpha, 1 plus alpha will be new value of resistance. It is very obvious that the resistance will increase with respect to temperature. Higher the temperature, higher will be the resistance. Now 1 plus alpha is the new resistance. Okay. Now instead of that, instead of raising the temperature through 1 degree Celsius, if we are raising the temperature through delta T degree Celsius or Kelvin, what will be the new resistance or the change in resistance? What will be the change in resistance? If for 1 degree Celsius, if it is alpha, for delta T degree Celsius, that will be alpha into delta T. Okay. Now, this change will happen for 1 ohm resistance. If it is R ohm resistance, then for R ohm resistance, delta T degree Celsius change, the value of the change in resistance will be R into alpha into delta T. Now what is this? This is increment in resistance, right? Now here in this example, we have taken a resistance having R. We have increased the temperature through delta T. What we have seen is R into alpha into delta T will be the increase in resistance. So what is the new resistance? The old resistance plus this value. So new resistance at a temperature RT is equal to old resistance R plus R into alpha delta T. So I am going to represent R as R0 because it's the initial temperature, right? So initial value like V0 and Vt in mechanics, we are going to take it as RT and R0. Now I am going to take R0 in common into 1 plus alpha delta T. RT is equal to. This is variation of resistance with temperature. Now how can we get the variation of resistivity with the temperature? For RT, you can substitute the value R is equal to rho L by A. Now anyway, with temperature, length and area remains the same. There will be slight variation for length that we have learned in class 11. When temperature increases, length also will increase, but we are not going to consider it here in this case. Okay, so RT is equal to RT is nothing but rho T into rho T into L by A. So L by A remains the same, but resistivity has changed, that is rho T. Now R0 will be rho 0 initial resistivity into L by A. Now into 1 plus alpha delta T. So L by A can be cancelled and RT is equal to this value. Sorry, rho T final resistivity is equal to initial resistivity plus into 1 plus alpha delta T. So this is very important relation. For resistivity, you can use this value, and for resistance, RT is equal to R0 into 1 plus alpha delta T. You can use this value for variation of resistance. Now what is this alpha? This alpha is nothing but temperature coefficient of resistance. Now how we have got the value of alpha? That is nothing but change in resistance of 1 ohm resistance or 1 ohmic conductor when the temperature increases through 1 degree Celsius. So what is temperature coefficient of resistance? That is nothing but change in resistance of a conductor having 1 ohm resistance initially when the temperature changes through 1 degree Celsius or 1 Kelvin. I will repeat it. Change in resistance of a conductor having 1 ohm resistance when temperature changes through 1 degree Celsius. That is alpha. That is nothing but temperature coefficient of resistance. Thank you.